I can figure it out
Please.
also.
Oh,
All right. Videos aren't great. I'll take a look.
no.
The video is still loading.
I sent you a photo.
Oh, okay. They're coming in now. All right, let me go to my phone, be a little faster. Yeah, so e to the x, sine x. Okay, we're going to do example 5 first, which is x squared e to the x.
Okay.
And then we'll do this. So yeah, so if you see my screen, we'll get started here. So whenever you have, and this is the type, it's type 1, whenever you have a polynomial function of x, which is what x squared is, times e to the x, your u is always p of x, and your dv is always e to the x. Okay, so over here, let me just rewrite it here, x squared e to the x dx. Your u is x squared. Your dv is e to the x dx. So the one on the left here, you're going to take the derivative. And on the right here, you're going to integrate. That's why we spend so much time learning how to take derivatives and integrals.
Yes. So it's going to be 2x.
Yeah, so du is 2x dx, and v, the antiderivative of this, is e to the x.
Okay.
So the formula is uv minus the integral v du. So you take the
minus? Why?
Yes,
minus?
because that's what it is. This is like known. This is like a known formula. It's always going to be that.
Okay.
So you take
That's
your u,
v du.
Yeah, v du, yeah. So you take your u and your v, x squared e to the x, minus the integral e to the x, okay? And then your du is the 2x dx. So again, I'm just taking the out of the four things here. There's 4 things. I'm just piecing them together.
Okay.
So now on this on the right here, I'm just going to rewrite it. It's the integral of 2x e to the x dx, x squared e to the x. Okay, and then you have to do integration by parts again. Okay, so your u here is 2x, and your dv is e to the x dx. So your du is 2 dx, and your v is e to the x. Okay, so just this part right here, we got to do this again. uv minus the integral of v du.
This is the same question? No.
Yeah, same question.
Oh.
You have to do integration by parts a couple of times here.
Wait. Oh, I thought that was a different question.
No, it looks similar, but it's different. So
then
you bring this down. Well, yeah, minus. So we minus our uv. So like this integral is done over here on the right by parts. uv is 2x e to the x. This minus goes with this minus, plus integral v e to the x du is 2 dx. So you're just piecing these together, and so on. This is over here, and this one is there. So you're almost done. This one is just a regular integral. It's the integral of 2 e to the x dx, which you're supposed to know by now. Like this is like a known thing. It's just 2 e to the x. And then you bring this other stuff down. So x squared e to the x minus 2x e to the x plus 2e to the x plus c. That's your final answer.
Okay. Can you give me a question and I'll try to do it?
Sure. Let's do an easier one than this. Let's go so let's go integral x cosine x dx.
Oh, that's the question?
Yeah. Yep.
Okay,
This is it.
so it's gonna be u equals cos.
Nope. U is always the polynomial function.
What is polynomial function?
Polynomials are like x squareds, x cubes, square root of x's,
Here,
stuff like that.
u equals x dv equals cos dv or du? dv, right?
It's dv. Yeah.
Now the dx equals to, or there's no dx. dx.
The dx goes over here on the right because you're actually integrating both of these. So it ends up being v equals sine x, and then du equals dx.
No, last time we did it like dx equals dv over something, or no?
No, we didn't do
du.
that. I mean, last time you're just taking the derivative and then integral. Like there is an integral here in all these, but you don't have to write it. I don't know if your instructor is or not isn't. Same thing here. Like you could integrate these, but basically it's a derivative and then an integral.
Okay, so the first step we find the u, then the second step is we find the dv,
Yes.
which is the cos.
Yes.
How do you know that that's a dv? Like,
So I know because I know that this is this type one. This type one, it's a polynomial times e to the x, sine x, cosine x. As a student, you do a lot of practice and then you figure it out. Because on the test, it won't tell you. It'll just say to integrate this.
okay.
So practice helps, I guess. So uv minus integral v du. So it's x sine x minus integral sine x dx.
Wait, what?
So here's your u. Here's your v.
Wait,
Here's your v again.
wait, what happened to the d?
What do you mean
the dv? The dv, it's gone. The d.
We don't use it. The dv is not used in this.
Then how did he get dv? The derivative of cos?
No, you integrate you integrate
The
dv
integral of cos.
to get v, and then the integral of cosine is sine.
Okay. Okay.
Okay, so what is the antiderivative of sine? It's minus cosine, but there's a minus there, so it becomes plus cosine x, and then plus c.
Yeah.
All right, do you want to officially try one on your own?
Yes.
All right, so let's go integral x plus 2 times e to the x dx. Go ahead and give this a try, please.
So the u is e to the x. Oh, plus
Sorry,
2.
I'm sorry, u is x plus 2, dv is e to the x dx.
This is going to be just x.
So du equals dx, and then you're integrating both of these, so v equals e to the x.
Wait, why do uv?
It's always uv minus integral v du. Like this is just, it's always this.
So I did not substitute anything.
Nope, you
Not
now
yet?
can.
Oh.
You have, now you have the things you need to substitute.
So I must memorize this uv minus the integral of v du.
Yes.
Okay. Now I have the uv. No, I don't have the u. I have the u, which is e to the x, and the v, which is dx. dx.
Nope, your u is x plus 2.
Oh,
Your v is e to the x.
integral of the x dx.
Yep.
Okay. Okay, so just substitute. Now you do it.
Now you can actually do
Okay.
this one. So it's
So the
e to the
integral of
x
e to the x. Yeah.
plus c. All right, so that's example 5. We can go back now and do example 4.
Okay.
If that's
I'll
okay
do
with
it.
you.
I'll do it.
No, you need
Oh.
some explanation on. So I'll do
Or can you give me one more example of this?
Sure. Let's,
And
because
I'll do it.
yes. Okay, so let's do this. Let's do integral x squared sine x dx. This is going to require integration by parts twice.
So the u is 2x or x squared. Just x squared.
Your u is x squared.
U is 2x. And the
And
dv
dv
is
sine
x
x.
2x. The sine. Oh.
Yeah. So maybe what's not clear is that I'm just trying to grab another color here, is that this is this, which becomes u, this is u, and this is all of this, which is dv. So you're integrating this.
Okay.
Like you have to use up everything. You have to use up everything in this integral
Okay.
to do it.
Okay, now it's clear. It's clear. It's clear. Okay. X dx. Now du is 2x.
2x dx.
Oh, I have to put the dx.
Yes.
2x. And the v is negative cos
Yes.
x dx. No, without the x dx.
You're integrating. So when you integrate, the dx goes away.
Okay. So the u, we just take the derivative and the dv we integrate.
Yes.
Okay. So now uv minus the integral of v du.
Say that again.
uv minus the integral of
Yes.
v du.
Very good. Yep.
Then uv is x squared
Yep.
d
X squared.
dv
V
and
is
the
minus
v
cosine X.
equals minus no I put in
Right. You're just moving things. You're just moving things around, you know, getting them into the spot here.
with the v. The
V
v
is
is
minus cosine X,
okay,
right? So that's
minus
why it goes to a plus.
with and it's a negative. Why?
Y is what
Why
negative?
it's a negative? Oh, okay. I get it. Positive.
Yeah. So once you get here, you got to do a little bit of rewriting here. It's integral 2x cosine X dx. And you have to do integration by parts again.
Yes. The integral of cos is no. Integral of 2 is 2 over just 2 dx.
Yes.
Oh, we have to do this again.
Yep. Integration by parts twice.
No, wait. I'm confused. Wait. Cos x times 2x dx. I got here to the dx.
Okay. So you've got all this down? Because this is integration by parts again. It's uv minus integral of v du. That's why we have all this stuff on the right.
Which what? I'm trying to figure out what you did between the first and second.
Well, just to be clear, like we did integration by parts.
Yeah.
But you keep doing it until you're done.
How do you know if you're done?
When the integrals are all gone.
Oh.
Yeah, the integral's still there. Like you got to
Yeah.
do this on the right. It's not done. So this is it's almost like a brand new problem. You know, this right here in red. I mean, that's all this. Like it's a whole new problem. And then this other part just keeps coming down since you've already done it. Like done. So you're going to bring it down. So you do integration by parts over and over again until you're done.
Okay, I'm done with that. Then, okay, you bring down the negative x squared cos x plus then the integral 2x. Okay, why did you put the 2x over there? Why did he move it?
Move it in front. Just preference. It's better. I like it in front. Most people like polynomials in front of trigonometric functions.
Okay.
Okay. So then you do it again. So you get your u and your v. You got your u and your v. And then you got your v and your du. So you go plus 2x sine x, because u is 2x, your v is sine x, minus integral v is sine x, du is 2 dx. And then you bring this first part down.
Wait.
Just substituting, you know, that's u, that's v. That's v again.
to x. Okay.
That's du again.
dv. Okay, the rest. Okay. 2 dx. Okay. 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 After this, what?
Well, we got to integrate this on the right. Now you look at
Again?
it, well,
Oh.
but it's not integration by parts because you know this one.
Oh, it's gonna be the integral of
So minus
negative
cosine, yeah, negative
cosine.
cosine, but there's a 2, but then there's a negative in front, so it's plus 2 cosine x. And you're done.
Oh, yeah. Is this like considered like one of the hardest or no?
No, no, this
No?
is one question out of like 9 that you'll get on your test.
Oh,
Maybe because you could get the example 3, or I'm sorry, you could get like example 4 or example 6. We have no idea.
okay.
Okay, let's go look at example 4 type, but I'm going to change it up and then we'll come back and do this one. Integral e to the x cosine x dx. Okay. So this time I'm going to let u equal cosine x and dv equals e to the x dx. So du is minus sine
minus
x
sine dx.
dx, and v is e to the x. Okay, so the integral, and I need to write it this way for this one, equals, and it's that uv minus integral v du. Okay, so the integral of this thing is cosine x times e to the x. So it's e to the x cosine x. I can switch the order, that's fine. Minus integral. So it's e to the x times this sine x, but it's negative. So I'm gonna make that plus e to the x sine x dx. So I'm just substituting in here all the things we just did. uv and du. You don't use the dv anymore.
Okay. Now,
So now you got to do integration by parts again on this thing right here.
okay, so the u is going to be e to the x.
U is going to be sine x and dv is e to the x. You generally choose to integrate the function that like is easier, and I guess e to the x is slightly easier to integrate. So du is cosine x dx and v is e to the x. So and just to be clear, we're just working on this part right here. This part right here is the uv minus integral v du. All right, so that's e to the x sine x, okay, minus the integral of e to the x cosine x dx. Okay, now this is very important. So we're going to bring this other stuff down. E to the x cosine x plus, and then remember, this is what we started with. We started with this over here on the left. Now, do you see that this is the same as this? On the left is the same as this on the right.
Yes.
So this is not correct, but if you were to add the integral e to the x cosine x dx to both sides of the equation, how many of these do you have now? You have 2. Do you see that? I'm gonna do it in red here. You have, well, actually, I don't like red. Red's a bad color. 2 integral e to the x cosine x dx equals, and then you bring this stuff down, e to the x cosine x plus e to the x sine x. And then you divide both sides by 2. So your integral e to the x cosine x dx equals this right here. And that's your final answer. Plus C. Okay, so this example 4 type, you always do integration by parts twice. And then you move to the other side of the equation. And then you divide. You always do this for these type of problems. So your example is exactly the same way. So your example 4 is integral e to the x sine x dx. Okay, so what's that?
So this is the question that I'll do right now?
Yeah, if you want to try this one, you can, yeah.
Okay, I will.
Okay.
Wait, I got. Wait, I'll send you what. I'll send you on WhatsApp what I.
Well, you can send it, but the thing is you just gotta follow the signs. The UV is negative, and then this is positive, but because of that negative there, it becomes negative.
No, it's not about that. I think I did something wrong. After I substituted wrong or something.
Okay, well, where's your U and your DV? Did you got to write them out? I mean,
yes, I did.
Okay. Well, I mean, it's, yeah, you've got e to, it's, so your UV is e to the x cosine x. Oh, I'm sorry, you're up here. I'm sorry. So it's sine x e to the x. I mean, that's what you got. You got that.
Yeah.
Minus integral v du. Your derivative of sine is cosine.
Oh, it's not negative sign.
No.
Oh, yeah.
And it's
The
not,
integral.
and you're not subtracting. It's the negative of like it's the product because you're merging them together.
Okay. So when I substitute it, I got sine x equal to x dx. No, e to the x without the dx. Minus the x. Wait, with the integral or without? Without?
I'm not sure where you're at. I mean, do you want me to just start over on this problem?
Yes.
Okay. So we have integral e to the x sine x dx. So your u is sine x and your dv equals e to the x dx. So what is du?
Du, it's going to be negative cos.
Negative cosine
No.
x. And your v?
Negative. Oh, okay.
Your
The
v is
v
the integral. What's the integral of e to the x?
is e to the x. Okay. Then
Okay.
uv
So now
minus the
uv,
integral.
right? Yep.
uv
So
minus the integral of v du.
that's right. So it's e to the x sine x is uv minus the integral. V is e to the x.
It's not sine x, e to the x minus
E to the x sine x, that's uv.
or sine x e to the x or no?
The order doesn't matter, but it's better to
Okay.
put e in front of sine.
Okay.
Minus integral v du. So v is e to the x, du is minus cosine x, so you change that to a plus, e to the x cosine x dx. Is this okay? Is this clear?
Yes.
Okay, so you got to do it again. And we'll change colors. Might as well change colors. Maybe that'll help here. Let me go blue. Okay, so this part's in blue. So this is u is cosine x, dv is e to the x dx. So you have your du. What is your du? What's your derivative of cosine?
It's negative sine x
dx. And what's your integral of e to the x?
dx. E
E to
to
the x. Okay, so now just this part in blue is the uv minus integral v du.
Wait, question. How did you put the extra equal to itself? No, to. I mean, like, why did you put e to the x sine x dx on the left one? Look at the left.
This one over here?
Yes.
Because we're going to come back around and use it at the end. So we have to keep it going throughout the whole problem.
So that's the question, right? That's
right,
the question.
right.
Okay. Now I'm getting
right, I feel like we have a sign error though, so the derivative of sine is cosine, not that. That's a sign error. So this should have been negative.
The derivative of sine is cosine?
Yes.
Okay, what if, what's the integral of sine?
Minus cosine.
Okay.
Okay, so that affects, that affects this next line here. So it's minus UV. That minus is that minus. UV is cosine x e to the x. So e to the x cosine x. This minus goes with this minus. Minus a minus makes a plus. So it's plus integral v du. But see how there's a negative there? So we change
Yeah.
this to plus to minus. Sine x e to the x dx.
Okay.
So you got e to the x sine x equals integral e to the x sine x dx. Okay, and then you got this one here, which is the same. This in green. These are the same. So you literally move this to the other side. You add to the other side. Other side.
Yeah. Is it going to be 2 integral e to the x sine?
Yep, 2 integral e to the x sine x dx equals e to the x sine x minus e to the x cosine x, and then you divide by 2.
That's it.
That's it. You will get a problem like either this one, e to the x sine x, or e to the x cosine x on your exam. That's like for sure. They always test this. So you gotta really know these two types of problems.
Okay.
All right, we can do example 6 next.
Okay.
If you would like, or we can
Or you can give me one more question. Like I'll do it. I'll do it.
these are it. There's no more.
No, there's no more.
There's those two. I mean, the variation has to like put like a 2 in front or a 3. I mean, but they're all the same. We don't want to.
Okay.
So the next type here, this is like type 3. Let's not do the one that's there quite yet. Let's do integral x natural log of x dx. So this time, like you normally think that u should be x, but it's not. It's natural log x.
Mhm.
And dv is x dx.
X dx or just dx?
The dv always has to go with a dx. So now what is du? What is the derivative of natural log of x?
The derivative of 1 over x.
1 over x dx.
It's going to be x.
And the
No,
integral of v is, or the integral of
Yes.
x is
dx.
1/2 x squared.
Oh.
So you're going the other way. You're integrating, not taking derivative. So it's uv minus integral v du, like we've done over and over again. They're all the same. uv minus integral v du. You have to know this really well. So you multiply u and v. So that's 1/2 x squared natural log of x minus integral. Your v is 1/2 x squared. Your du is 1 over x dx. You're just substituting in. So like, is it clear where these came from? How I just put these into the formula? Yes, no, maybe.
Yes.
Hamad, are you still with me? Okay.
Yes.
Okay, great. Okay, so this one on the right actually simplifies. It simplifies nicely to well, this one of these x's cancels one of those x's, so it's 1/2 x dx. And the integral of this is just power rule. So it's 1/2 x squared over 2. Just bring this down. And then you can clean it up.
So, wait, what happened? You brought it. No.
So you just multiply the values here.
Wait, what happened to the 1 over x?
What do you mean? You multiply x squared over 1 times 1 over x.
Then what happens to it?
Becomes just x. So you get 1/2 x, and then you integrate that.
Integrate it. Now it's gonna be 2 over 2. Okay. Can you do this? What, -1 over 4? Not -4 x?
What the antiderivative of x is x squared over 2, and the 1/2 just comes with it.
Okay. Okay.
All right, so that's your final answer for that. So we'll do another one here like this. Integral natural log of x dx. This is a classic exam question. So your u is
natural log
x,
of
yeah,
dx.
and your dv is dx.
Natural log of x dx or no?
No, you have to. dv is just dx because there's nothing else. There's nothing else that's with it.
X dx or just dx?
You've used up the natural log of x over here, so there's just dx. That's all that's left over.
D is 1 over x.
du is 1 over
dx,
x dx, and v is x. So uv minus integral v du.
So the u is the natural log of x, and the v is x. So, x squared? X squared? No.
So uv
No,
is x natural log of x. You can't multiply what's inside.
Why x natural log of x?
Because u is natural log of x and v is x.
Oh, you put it over there. You
Yes.
can't put x beside x? No.
Well, you can, but you might do what you said, which is think it's natural log of x squared, which is not
Oh.
right.
Okay. So minus the integral of v, which is
Minus integral of x times 1 over x dx. So this is x natural log x minus integral dx.
So it's what? Oh, so this is going to be. Wait, how? How did you do that?
Well, x times 1 over x is x over
X
x,
over X.
which is just 1, and you don't write 1, you just write dx.
So just dx.
So it's minus
Okay.
x plus c. Because the integral of
and the
dx is x.
Oh. Okay.
All right. So that takes us to the end of our lesson for today. Do you want to schedule for tomorrow afternoon or evening? Do you have a preference?
Tomorrow, wait, I'll take a look at my schedule right now.
Okay.